Star clusters. When we look at a cluster of stars, what we are looking at is a group of stars formed from the same cloud of gas. At the same time. So, here we're looking at a whole bunch of stars. They're all together in one place, and they are all essentially siblings, but born at the same time. So way beyond septuplets at this point. But all of these stars are formed out of the same gas, formed at the same time. And that has some advantages as far as studying the life cycle of stars. So one, they're all going to be about the same age. So that's handy because then we can compare differences due to different masses without worrying about how old is this, because they're all going to be the same age. They're all also the same distance, since they're all grouped together. It's in a cluster. So that means we don't have to worry about differences in brightness having anything to do with distance. So the effect of distance on brightness is not going to be an issue. So when we look at a cluster, stars that look really bright, they really are much brighter than the stars that look really faint. So we know, okay, we've got really bright stars in this cluster, we've got really faint stars in this cluster, and that truly is a difference in their luminosity, not just an effect of distance. Now we know different masses age at different rates. We know high mass dies fast. And low mass dies slowly. So even though all of these stars are the same age, they won't all be at the same stage in the life cycle of a star. So we can actually look at a whole variety of stages all at the same time, because you're going to have, for the very lowest mass, they might still be forming. So you'll have protostars. All the way up to the highest mass might be in the giant stage or beyond. So you're going to basically get a snapshot of the entire life cycle of a star all in one place, because you're going to see stars forming, stars that are main sequence, orange giants, red giants, and beyond, all in one place. Now there are two general categories of star clusters, and the first type is called an open cluster, and it's open because over time the stars will drift apart. So it is not gravitationally bound. Ran out of room. And so the fact that it is still a cluster, it has to be younger because it hasn't had time to fall apart yet. Now, because most stars do form in a cluster, but we don't see all stars in clusters. They were parts of open clusters. That's true of our sun. When our sun first formed, we were likely part of an open cluster. And our sun's stellar siblings have drifted away, and so we don't know who our brothers and sisters are anymore. But this is true for most stars, that they're going to drift apart. Where we see open clusters is in the disk of our galaxy. So here we've got an interesting perspective on the galaxy, but the big round flat part, that is the disk. And that's the part of the galaxy where we do see open clusters. Now the other type of cluster is called a globular cluster, and the name refers to the shape because they are round shaped. And these are gravitationally bound. So these have enough mass to actually hold themselves together in a cluster. These typically have millions of stars in them. Open clusters are much less than that. Open clusters are typically on the order of hundreds of stars. So very, very dramatic difference there. So these are older because they are still held together. They're going to last a long time. And these are typically found in the halo of our galaxy. So here in the picture, here's another image where we can see the disk, but the halo is this region around the disk. So above and below the disk is the halo of our galaxy. And all these little fuzzy things that you see here, those are the globular clusters. And so you can see, compared to the entire galaxy, they're pretty good sized. Obviously not as big as the galaxy, but big enough that you can see them on this scale, whereas an open cluster would be far too small to see on this scale, even though they've actually labeled one there, but it would not really be that big. It would be much, much smaller than that. So whether we're looking at open clusters or at globular clusters, in both cases we're looking at a group of stars that formed at the same time out of the same cloud of gas and dust, is all one distance away for a given cluster. So if we were looking at this cluster, everything would be essentially one distance away. And we can get this snapshot of all these various stages in the life cycle of a star by looking at a star cluster.